Welcome back, guys. Today we are going to be talking about molarity. Molarity is the concentration or the strength of a solution. So in class we've talked about solutions. Solutions are made of two parts, a solute and a solvent. And if you recall, the solute is what is actually being added and dissolved. The solvent is the primary liquid which will be doing the dissolving. So the solute and the solvent are terms you should be familiar with when dealing with solutions. And molarity refers to the relationship or the ratio of solute to solvent. It tells you how strong or how potent the solute is in the presence of your solvent. So the more solute you add, the higher the molarity is going to go. Now, we mathematically define molarity as moles of solute over liters of solvent. Now, this is important because we have very specific units here, and this is one of the first times that you guys are going to start seeing specific units that are required. Now, we're going to see a lot more of it with gas laws and other equations that come down the road. But right here, molarity, by definition, big M, molarity needs moles, not grams, okay? It needs moles of the solute, only the solute, and it needs liters of solvent. So if you're given milliliters, you need to comfortably be able to convert into liters. And just as a reminder, let's say that I have 150 milliliters. In order to convert that, some of you see that you just moved the decimal back 3 places in your head, and that's great. For those of you that don't necessarily see that, we put milliliter over here to cancel out, and we put liter up top. Now, if you don't remember how to do conversions, go back and watch the video on that, and this should make more sense. You always want to put the 1 for the larger number, and then for the larger unit, and then the larger number goes with the smaller unit. So 1,000, because milli is 10 to the third. So milli is really 10 to the minus third. 1 over 1,000 is the same as 10 to the minus third. So if you did that, it would come out to 0.150 liters. And the milliliters cancel out. So it's important. Molarity is moles of solute over liters of solvent. Okay. So let's look at 2 examples, and that should be able to pretty accurately sum up molarity in calculations. So please forgive the points that are associated with this. These were questions I gave out in various quizzes and homeworks throughout classes that I've had. But let's use these for practice. Suppose that you're given 550 milliliters of a 2.3 molarity solution of aluminum trichloride. All right? So, how many moles of the aluminum chloride would be present in this solution? So we want to find the moles. If we go back and we look, molarity is equal to moles of solute, the aluminum chloride, over liters of solvent. So we're going to assume that we are dissolving this in water. All right? So when we look at this, the volume that we have is 550 milliliters. So let's first convert that to liters. We're going to do it just like we did before. For those of you that need to follow that. Sorry, let me erase that so it looks a bit cleaner. So we have 550 milliliters. And we're going to turn that into liters because that's what's required by our molarity solution. We need liters of solvent. So I say 1 liter is equal to 1,000 milliliters. And if I solve this, it will come out to give me 0.550 liters. And you can check that. You can put it in a calculator. All right. So what else are we given? We're given the molarity of the solution. The molarity of the solution is 2.3. So when we're doing this, we're going to turn around and we're going to say, all right, let's look at the equation. Molarity is 2.3. I want to find the moles of solute, and I have the liters of solvent. So the way I would set this up is 2.3, that's my molarity, is equal to X moles of AlCl3 and then I'm going to put that over 0.550 liters. Now, the next thing you need to do is algebraically solve for x. We're going to do that by multiplying both sides by the 0.550 so that this bottom will cancel out. And then when I multiply these two, it should come out giving me my moles of x. So if I do put this into a calculator and I type in 0.550 times 2.3, what I'm going to end up with is 1.265 moles. And given that we had 2.3 and 0.550, if we were minding our sig figs, we would round this up, dropping this part and saying that we have, let me erase part of this here so we have some room. So we would end up saying that we have 1.3 moles of AlCl3. So hopefully you guys followed that. We essentially took the molarity, plugged it in, turned the milliliters into liters, plugged that in, and then solved for X number of moles at the top. That came out to 1.3 moles of aluminum chloride. Now, these problems are all solved the same way. However, it can get a little more complicated if you have to take it past moles. So you should be able to solve for molarity, for liters or volume, and for moles. Now, let's say that we want to find the grams of solute in a solution. Well, I would start the same way. All I would need to start working with is the molarity equation to find moles. And once I have those moles, I could move that over and start working with grams. So, let's take this example here. A sample of seawater is determined to have a molarity of 2.57 m. So that's the molarity unit. The sample taken was measured to be 150.7 milliliters. Given this information, find the grams of sodium chloride that's dissolved in the seawater. Show all work. And again, the points are there because this was a problem that I gave. So, if I wanted to do this, I would need to convert my milliliters into liters. I'm going to just save space this time and tell you it's 0.1507. So I moved the decimal back 3 places due to it being milli. So this is going to be my volume, and I have 2.57 as my molarity. So I can find moles of the salt, and then I'm going to need to convert it into grams. So for the molarity, I've got 2.57 equal to X, because that's going to be X moles of NaCl. So this is X NaCl in moles. And then at the bottom, I'm going to have my volume of 0.1507 liters. I solved this the exact same way. I'm going to multiply the two of these together so that it'll cancel down here. I bring it and multiply it up by the 2.57, and I'll find my moles of NaCl. So if you take 2.57 times 0.1507, and you plug it into your calculator, you're going to find that X is equal to 0.387 moles. And that's moles of the NaCl. Once I have that, if I want to convert it to grams, I need to go and find the molecular weight of NaCl from the periodic table. And I can tell you guys right now, sodium is approximately 23, the chlorine is about 35.5, roughly in that area. So what you would do, if you actually add all of that up, you're going to take 0.387 moles. You know what? Let's do this on a new screen. You're going to take 0.387 moles of sodium chloride, and you're going to convert that into grams. So it would be grams, and then mole is down here because I want to get rid of moles, cancel the moles out. Every 1 mole, if you add it up, it comes to around 58.44 grams of sodium chloride. Again, this number, 58.44, came from the periodic table. I had to take sodium, find its weight, and then add it to the weight of chlorine from the periodic table. Once I'm done with that, if I take 0.387 times 58.44, I'll find that the total weight comes to 22.6 grams of sodium chloride. So keep in mind, you could take anything once you have it in moles to another step. So I could take moles if I've solved for it and find grams. I could take moles if I've solved for it and find number of atoms or particles that are present in the solution, because all I would need for that is Avogadro's number. So to conclude, let's talk about molarity one more time. If I want to solve for molarity itself, it's going to be moles of solute over liters of the solvent. What if I want to solve the other ones? Well, I have to isolate them first. So let's say that I want to solve for moles. That's what we've been doing with a lot of these. I'm going to turn around and I'm going to say, well, moles can be by itself on the right if I multiply each side of the equation to liters. So liters would cancel out, so let's do this again down here. Molarity equals moles over liter. If I times liter on both sides, I get moles by itself. So moles is equal to liters times molarity. All right? And then finally, what if I want to find the liters? If I want to find the liters, I can do the same thing. I'm going to do molarity equals moles over liters. If I want to get liters, I need to get it by itself, and it's in the denominator right now. So let's get liters, just like we did before, away from the bottom. That gives us moles equals liters times molarity. Now let's get molarity away, and we'll say divide through by molarity, and that gets liters by itself. I have to divide through by molarity here. So in order to find liters, liters is going to be equal to the moles divided by the molarity. So algebraically, we can look at molarity equals moles divided by liters, moles equals liters times molarity, and liters equals moles divided by molarity. So be able to manipulate and go through all three of those forms, and you should also be able to take your moles one step further. You should also be okay with converting liters and milliliters back and forth. So hopefully this has explained your molarity concept. We're going to talk about dilutions in a different YouTube video in which you can reduce the molarity if you're given an initial molarity and you want to get a final molarity. So we'll talk about that next time. Remember to thumbs up the video, leave comments if it helped. Subscribing is the best way to figure out when new videos have been released, so I appreciate you guys subscribing to my channel. And other than that, I hope this was helpful, and I'll see you for the next video.